the Lewis structure of the carbonate ion. The carbonate ion has the formula CO3 and carries a 2 negative charge. So if we're to do our accountancy, we need carbon and 3 oxygens, and these 3 oxygens, each of these 3 oxygens is in group 6, so the 3 oxygens provide 6 electrons each. That's 18 electrons. Carbon provides 4 electrons, that's 22 electrons, and we must add in 2 extra electrons for the 2 minus charge. So there are 24 electrons altogether to be added in. Now carbon's in period 2, so it can't undergo octet expansion, which means that it must be bonded to the oxygens via normal covalent bonding. So carbon can bond to 1 oxygen by 2 shared pairs of electrons, 1, and this will fulfill the requirements of this oxygen, because this oxygen has donated 2 of its own electrons, so it remains with 4 electrons. 1, 2, 3, 4 electrons. This oxygen then has a full octet. Now we've used up 2 of carbon's electrons. It only has 2 more electrons left. So it can share 1 pair of electrons with an oxygen. So we can make 1 bonding pair here. And now the oxygen has only got 7 electrons of its own. And let's put this electron down here. Well, no, let's use this. We'll add in 1 of the 2 extra electrons that we've got, because remember we can add in 2 extra. We're adding in 1 of this oxygen, and we can do the same thing with this bottom oxygen here. We can bond using the last carbon electron. So carbon has used 1, 2, 3, 4 of its own electrons, the crosses in this case that represent the carbon's electrons, and oxygen has got 2, 4, 5 more electrons plus the 1 for the charge. So if we add up the total number of electrons here, around this oxygen there are 8, around this oxygen there are 8, and around this oxygen there are 8. 3 8s are 24. So this is the structure of the carbonate ion, the Lewis structure of the carbonate ion. Of course, the actual structure will not have 1 double bond and 2 single bonds. All 3 carbon-oxygen bonds will be equivalent. In terms of the ionic shape, there are 1, 2, 3 regions of electron density around the central carbon, and so it adopts electronically a trigonal planar shape, and as there are no lone pairs of electrons, the ionic shape is also trigonal planar.